Okay, fourth grade numbers and fractions, third standard decomposing fractions, part 2. Okay, there will be some more added to this video. I wanted to show students how to use decomposing to add and subtract. We started with this example right here. We took 1/4 plus 2/8. Students need to understand that the only one that needs to change is the one with the smaller denominator. We want to draw bar models to see what is the relationship between fourths and eighths. Well, when I drew the bar models, I realized that 1/4 is equal to 2 1/8. So I changed 1/4 into 1/8 plus 1/8, and then I was able to add them. I know I can't add or subtract fractions if the bottom numbers are different. So I'm going to use my knowledge of bar models and decomposing fractions to add and subtract. Well, I showed them a new way down here. Same way we do denominators of 10 and 100, adding and subtracting them anyway. We're only changing the denominator, or the fraction, with the one that has the smaller denominator. Down here, 4 has the smaller denominator. Well, if this was a 10 and this was a 100, we would multiply by 10 to generate the equivalent fraction. But since this is a 4 and an 8, you ask yourself, how do you get from 4 to 8? Well, I multiply by 2. Well, do the same thing to the top, and it'll both have the same denominator. Now I can add straight across, and as you can see, I get the same answers. Over here, let's do this one. I'm going to draw my bar models for which ones, people?
4,
6, and
2/3.
What's important about the bar models when I start out? They have to be the same what? They have to be the same what?
Size.
They have to be the same size. And every fraction start out as a what?
One whole.
One whole. So we made a whole bar. Now we're going to break it up. Okay? I need to break this top bar into what? And I know my drawing is so off. I need to break this top bar into how many? 6. I need to break this bottom one into how many?
Wait, 3.
Threes. Okay. Up here, what unit fraction goes in each box?
1.
How many do I shade in?
4.
4. What unit fraction goes down here?
2/3.
Unit fraction.
1/3.
1/3. And I think you knew what I was asking. You just said it wrong. How many do I cut shade in, Davion?
2.
Do y'all see a relationship between thirds and sixths? Which one won't change?
4, 6.
Why?
Because
Bigger denominator. Which one will change?
2/3.
It's gonna have a denominator of what?
6.
Say it again.
6.
Why? Because to add or subtract fractions, they have to have the same what?
Denominator.
How many 6 is in 2/3? How many 6 is in 1/3? 2. So I'll do 1/6 plus 1/6. But how many thirds do I have? 2. So how many times do I need to write 1/6? When I look for 1/3, how many 1/6 are shaded over it? 1, 2, 3, 4. So I need 4 of them up here. Doesn't that make sense?
Mm-hmm.
Can I add them now? Yes, eyes on me. Pencils down. I know my denominator will stay what?
6.
Count with me. 4 plus 1. 5 plus 1.
6
Plus 1.
7
Plus 1.
8.
Can I leave it as 8 over 6?
That's improper.
That's improper. It's a bodybuilder. The top is bigger than the bottom. I need to change that to a mixed number. I told you when you hear the term fraction, what operation should you think about?
Division.
Division. Say your division problem.
8 divided by 6.
Watch me. If I do 8 divided by 6, if I subtract 6 from 8, I get a 2. Can I subtract any more? No. How many times did I subtract 6?
3.
Once. That 1 goes up there because I only subtracted once. So my big number and my mixed number is going to be 1. My fraction, my denominator is going to be,
6.
and my numerator, what's the
One,
number?
two.
2. the remainder of 2. So that's my mixed number. Well, how do I go from a mixed number to an improper fraction? How do I check it? How do I know if that's right?
Oh, Mr. White, you multiply the denominator from the whole number
And then add
the
6 times 1
6
plus 2.
8.
8 over 6.
Yeah, triangle.
Well, again, you can use either way. I just want to make sure you get it right.